two methods can be used to solve problems involving constrained optimization, and these are the substitution method (SM) and the Lagrange multiplier method. The substitution method involves transforming a constrained optimization problem into an unconstrained one. This is done by first solving the constrained equation for one of the decision variables and then substituting the expression for this variable into the objective function that the firm seeks to maximize or minimize. Salvatore, 2007, page 63. Now, let us look at an example involving a constrained optimization problem using the substitution method. Example: maximize total profit equals negative 125 plus 100y plus 50z 5y to 10z 2 plus 10y's. Subject to y plus z equals 10. Step 1. Solve for z in the constrained equation. Z equals 10y. Step 2. Substitute z in the object function equals negative 325 plus 350y 25y2. Step 3. Find the derivative of the new objective function. Dysprosium equals 350 50y. Step 4. Equate to 0 and solve for y. 350 50y equals 0. 350 over 50 equals 50y slash 50. Y equals 7. Step 5. Now solve for z in the constrained equation. Y plus z equals 10. Z equals 10. 7 equals 3. To maximize profits, the firm must 7 units of product Y and 3 units of product Z. Lagrange multiplier method (LMM). At this point in time, we would to solve the same optimization problem using the Lagrange multiplier method. Maximize equals negative 125 plus 100y plus 50z 5y to 10z 2 plus 10y's. Subject to y plus z equals 10. Step 1. Equate the constrained equation to 0. Y plus z equals 10. Y plus z 10 equals 0. Step 2. Multiply the constrained equation by lambda. Question mark y plus question mark z negative 10. Step 3. Add the new function to the objective function. Equals negative 125 plus 100y plus 50z 5y to 10z 2 plus 10y's plus question mark y plus question mark z negative 10. Step 4. Find the partial derivatives of question mark with respect to y, z, and as shown below. D dy equals 100 10y plus 10z plus e. Dawson equals 50 20z plus 10y plus d equals y plus z 10 equals 0. Step 5. Solve for y, c and equals 10y 10z 100 equals 10y plus 20z 50. Y plus z equals 10. 10y 10z 100 equals 10y plus 20z 50. 20y 30z equals 50. 30y plus 30z equals 300. 50y slash 50 equals 350 over 50. y equals 7, z equals 10, 7 equals 3, equals 10 7, 10 30 100 equals k 60. The meaning of Lagrange. The meaning of the is that if the constraint is increased or reduced by 1 unit, profits will be increased or reduced by k60. In the example above, if the output level is increased from 10 to 11, profits will increase by k60. In the same vein, if output is reduced from 10 to 09, profits will reduce by 60. Activity 2. Shallow limited of polar faces of following constrained minimization problem. Minimize. Total cost TC equals 3x2 plus 6y2 xy. Determine cost minimizing output levels of commodities X and Y subject to the condition that total output must be equal to 18 units using the substitution method. Use the Lagrange multiplier to verify the answer you have found in part I above. Calculate minimum total cost 4.0 Conclusion. Firms operate in the face of limitations or constraints. Therefore, in order to achieve their objectives, they need to conduct a process of optimization. Optimization involves maximizing or minimizing an objective function, which may or may not be subject to limitations. Firms maximize profits or sales and minimize cost over time. Unconstrained optimization is a situation where the objective function being maximized or minimized is not subject to constraints. On the other hand, constrained optimization occurs when the firm is trying to maximize profits or minimize costs in the face of constraints such as limited skilled labor and limited raw materials. Summary. In this unit, you have learned that there are two types of optimization problems, namely unconstrained optimization and constrained optimization. Differentiation can be used to compute unconstrained optimization problems. You can use the substitution method and Lagrange multiplier method to calculate the optimum quantity and price given the total profit function of the firm. In the next unit, we look at demand and revenue analysis, which deals with the factors affecting demand, the relationship between demand and revenue, the distinction between change in demand and change in quantity demanded, tutor marked assignment. Shallow limited of polar faces of following constrained minimization problem. Minimize. Total cost TC equals 2x2 plus or y2 xy. Determine cost minimizing output levels of commodities X and Y subject to the condition that total output must be equal to 12 units using the substitution method. Use the Lagrange multiplier to verify the answer you have found in part I above.